Okay, we are moving on to 1.3 today. It is an intense lesson that is incredibly important for our 8th grade standards. The topic is what's called real numbers. It means they exist. A real number means they exist. Your learning target, you can identify. Today it's just you can identify rational or irrational numbers. As we move further along, it says you can also order rational and irrational numbers. So you need to know what a set of real numbers is. There's 3 sets for real numbers. You can either be a whole number, you can be a natural, or you can be an integer. Okay? Whole numbers are how you count 1, 2, 3, 4, 5, and 0. Okay, so 0, 1, 2, 3, 4, all the way up to the lovely infinity. Write it down. So when I think of whole numbers, because it doesn't just come naturally for me. I looked at the word whole, and I think, oh, if I have a hole, it looks like a circle in my shirt, like I have a hole in my shirt. Well, look, 0 looks like a hole. So it's the numbers that have 0. No negatives. Natural numbers, again, try to think logically. Naturally, how do you naturally count? Everybody count right now.
1, 2, 3, 4, 5, 6.
Yeah. Beautiful. So you naturally start with 1, don't you? So 1, 2, 3, 4, all the way to infinity. Okay? So we have whole numbers, natural numbers. Whole numbers include 0. Natural starts with 1. It's how you naturally count. If you're playing hide and seek, you're not going to go 0, 1, 2. It's just not natural. You naturally start at 1. So the only difference between these two is 0. Integers are, the technical definition is a whole number and their opposites. So you just need to know it's negative numbers and the natural numbers. No decimals, no fractions. It goes from negative infinity to positive infinity. So whole, natural, integer. A number can be in all subsets. These are called subsets of real numbers, not just sets. So like the number 9, what set is the number 9 in? Ooh. Connor, what do you think? It's good. It can be more than 1.
Oh, more than 1?
Yeah.
Natural and whole?
Yeah. 9 is in our natural and our whole numbers. Is it in integers?
Yeah.
Well, yeah, it is. Because 9 is within integers, so it's in all of them, isn't it?
Yeah.
Yeah. What about negative 33? What set is negative 33 in? Eli? Integers. Can it be whole?
No.
Can it be natural?
No.
No, because they don't include that. So this would be integers. So one of your learning targets is to be able, if I give you a number, you tell me which set they go in. Okay? Now here comes the doozy stuff. Every real number is either rational or irrational. Okay? A rational number is a perfect square or a fraction. This should be perfect square root, actually. Can you write root down? Perfect square root. Or a fraction. Like the square root of 25 is rational, because it's a perfect square. Irrational numbers is not a perfect square. Or it's a decimal that doesn't repeat or have a pattern. Now this seems, some of you like this style of notes. I have a much easier one and coming up here in a couple slides. A much easier way to isolate them. And a square root. What the heck is a square root? It's a number when multiplied by itself gives you the number inside. So a number when multiplied by itself gives you the number inside. That's a lot of defining there. That's the boring part. We just need to apply it. Once we start applying it, it's not bad. So, the square root of 4. What number times itself gives you 4? 2. The square root of 4 is 2. This is a rational number because it's a perfect square. The square root of 25. Rational. What number times itself gives you 25? Tatiana? 5. And I want you to know like the first 11 squares. You're gonna need it, especially for tomorrow. I mean, you don't need to have it memorized for tomorrow, but we are using squares tomorrow big time. Square root of 121. Eli? 7 times 7 is 49. Noah? 11. 11 times 11 is 121. Okay. So, identifying irrational numbers. If it's the only thing you need to know, this is the easiest way I explain it to my 8th graders. Pretty much every number is rational. The only numbers that are irrational, there's 2. It would be the square root of not a perfect square and pi. Those are the only things that are irrational, okay? So if I have something like this, the square root of 32, that's not a perfect square. I would say that's irrational, okay? Everything else in the whole entire universe is rational. All right? So these are irrational. If it's not a perfect square inside the square root, it's irrational. Everything else is rational. So we're going to classify. The square root of 100. Is this a perfect square? Is there a number that can times itself gives you 100? So this is rational. This doesn't have a square or a square root sign, so is this rational or irrational? No. Rational. The only thing that's irrational is the square root of a not perfect square in pi. Everything else is rational. Even though it looks ugly, it's still rational. The square root of 37. Is that a perfect square? No. Irrational. Because it's not a perfect square. 3/4. Rational or irrational? Irrational is only if you're not a perfect square or pi. This doesn't have a square root. It's rational. Here's a square root. So this could be irrational. Now I'm going to check inside it. 12. 12 is not a perfect square. Irrational. Fraction. Fraction, it doesn't have anything to do with the square root, so it's going to be rational. 0.36 repeating. Rational because it doesn't have anything to do with square roots. The only thing you need to know as 8th graders, irrational numbers are going to be one of the 2. Okay? Okay, this is fun, right? Now, this is the last part of today, and I love, love, love it. It looks incredibly difficult, but usually the light bulb goes off within the second problem, and kids just, because it's kind of easier, they love it. So it looks hard, but a very easy concept, okay? Taking fraction square roots. If there's a fraction square root, it looks crazy, but it's got a really easy strategy. You take the square root of the top. You take the square root of the bottom, and then you simplify. So square root of the top over the square root of the bottom. I'm gonna show you. The square root of 9 over 36 sure does not look pretty. This is just the square root of 9 over the square root of 36. See how I broke that up? I took that big square root and I put it on the top and the bottom. What's the square root of 9? 3. What's the square root of 6 or 36?
6.
What's 3 over 6? 1/2. I don't have much room. That's it. That's all you do for square root of fractions. Just the square root of the top over the square root of the bottom. The square root of 16 over 9. The square root of 16 over the square root of 9. What's the square root of 16?
8.
Over 8/3, yep. Leave it improper. As 8th graders, leave it improper. So the square, oh, it's not 8, by the way.
4.
It's 4, yep. I think we divided by 2. Square root of 16 is 4. Square root of 9 is 3. Leave it at that. Okay. I want you to try to do the next 4. Then we're going to compare. Okay, so we are simplifying these fraction square roots. Again, they're rational numbers because they're perfect squares inside them. So the square root of 25 over 144 is the square root of 25 over the square root of 144. What's the square root of 25? What's the square root of 144?
12.
Nice. Perfect. Going down to the next one, this can get tricky because a lot of kids forget that 1 is a perfect square. What number times itself gives you 1? 1. Over, what's the square root of 4?
2.
How are you feeling on this? Right? You should always be checking, do I feel good about this? Do I feel like I could do this on my homework? Mm-hmm. Square root of 100 over 25, 2 different strategies you could use here. First strategy, you could simplify inside here. If you can divide, go ahead and do it. If you don't love the fraction, but perhaps you're in the zone with the fraction and you want to keep going that route. It's totally your call. I'll make a t-shirt. You could turn this into the square root of 4. Do you see how I did that? 100 over 25 is 4. Or the strategy I just taught you, the square root of 100 over the square root of 25. What's the square root of 4?
2.
Okay, and this turns into 10 over 5, correct? What's 10 over 5? 2. What's 10 divided by 5? Remember, a fraction is always a division problem. So, as you can see, this looks nicer, but we are equipped right now with handling it by breaking up the square roots. 36 over 2. What's 36 divided by 2?
6.
36 divided by 2. Are you?
18.
It's 18, but I hear you saying 6, so that tells me you went like this, right?
Yeah.
Okay. And then you get 6 on the top over the square root of 2. Uh-oh, I see a problem. Does anybody see a problem? Eli, what do you see?
I'll have that check mark.
The square root. I still have a square root. If it's not a perfect square, is it a rational number? No, so this